All right, independent and dependent events. Here's a warm-up problem. A fair coin is tossed and the probability of heads or tails are both 50%. To find the probability of flipping it a head or tails multiple times in a row, what you do is you just multiply the probabilities together. So part A, what is the probability of flipping heads 3 times in a row? So probability of heads, heads, heads. So you multiply 1/2 times 1/2 times 1/2, which is 1/8. Part B, what is the probability of a heads and then 2 tails? So probably heads, tails, tails. So you have 1/2. Oops, it says, and then tails, so we have 1 less here. So 1/2 times 1/2 is 1/4. In the box here, it describes independent and dependent events. The probability event that does not change probability from one trial to the next is called an independent event. For example, flipping a fair coin, rolling a dice, drawing a deck from cards with replacement. So I just want to highlight that, with replacement. Dependent events. A probability does change. The probability from one trial to the next is considered a dependent event. An example would be drawing a card from a deck and then not replacing it, and then you have 1 less card in that deck. So without replacement. You're welcome to pause and read further on this slide, explaining independent and dependent events. Okay, example 1. Tell whether each set of events is independent or dependent, and then explain. Pick Joe from a box of names, replace it, and then you pick Craig. So the big word here is replace. So this is considered independent because you replaced Joe's name in the box. Part B. You pick Joe from a box of names, you set it aside, and then you pick Craig. So this time, this is with no replacement. So the probability has now been adjusted to when you pick Craig. So this is considered a dependent. You roll a prime number on a number cube and get tails when flipping a coin. So if we go back to our description here, flipping a fair coin or rolling a dice is going to have equal. So this is considered independent. Roll an even number, and then an odd number, and then a number 1. Again, rolling a dice is independent. A teacher randomly selects 2 students from a class. This is considered dependent because the teacher selected 2 students, and once you select someone, that group's amount for the second student is now less. Okay. A deck of cards, sadly, it seems fewer and fewer people play cards these days, but we often talk about them in probability. So here's a quick intro of what you need to know for cards. There are 52 total cards in a deck. They are comprised of 4 suits: hearts, diamonds, spades, and clubs. Hearts and diamonds are red cards, and spades and clubs are black cards. Each suit has 13 total cards, starting with an ace and then going all the way up to our king. Example 1. Assuming you have a standard deck of cards, what is the probability that if you randomly select one card from a deck that you will get an ace? So the favorable outcomes, there are 4 aces in a deck, 1 of each suit, divided by the sample space of 52 cards. And then we reduce that fraction, 1 out of 13. Now let's say you draw an ace. You put that card back in the deck. What's the probability of drawing a king? Notice that you put the card back in the deck. So this is considered an independent event. So what is the probability of selecting a king? So a king, there are 4 kings in a deck out of 52. Again, reduce it, 1 out of 13. Now it says, what's the probability of both of these events occurring in a row? So now you have 2 events. You have the probability of the ace times the probability of the king. So what you do is you multiply those 2 events together. So 1 out of 13, 1 out of 13, then you multiply across, 1 out of 169. Let's take this back a few steps. Let's say you drew the ace, but instead of putting it back, you kept it and then drew the second card. This is now considered a dependent event because you did not replace the card. So the first event of getting an ace and then a king. So the ace is still 1 out of 13. But now the king, there are still 4 kings, but we have 1 less card in the deck. So we are now down to 51 cards in the deck when we take that king. Then we multiply across. So 4 out of 663. These 2 scenarios of keeping the card or putting it back represents the difference between an independent and dependent event. Which scenario do you think represents the dependent? And we talked about that already. So when you put the card back, this is considered an independent event. And then when we do not put the card back, it's a dependent event, and it affects the second event. When we took the king, we had 1 less card to choose from.